In this tutorial, we are going to continue our discussion on what optimization is. At this point, hopefully you are aware that optimization is a process of finding a minimum or a maximum for a given objective function. In this example, we're going to add on to our previous example of the constraint optimization example. In this example, we are going to impose what are called side constraints. These are limits on the design variables themselves. And here in dotted lines is what my constraints on design variables are. I'm going to say that x1 is allowed to vary between, I believe it's 1.5 and 4. And here I actually have it summarized here. X1 will be allowed to vary between 1.5 and 5, hence the dotted lines that you see here, 1.5 and 5. And then for X2, it's going to be allowed to vary between -5 and +5, hence you see these dotted lines here and here. So you can see these actually produce side constraints for this example. Let's look at what the optimizer does before we go ahead and go through the process of doing this in Nastran. Like before, Nastran will start at the initial point here, 3, 4. It will make a move towards the local minimum that you see here, but then it touches the side constraint first before hitting the design constraint we previously defined. Once it touches the side constraint or the limit on the design variable, it then further moves along the side constraint until it finds a better minimum here at 1.5, 0.06, and the z value is 2.25. So now let's go ahead and go through the process of setting this up for Nastran. Let's go ahead and move this window. And in the video description below, there's a link to 2 PDF files. Download these files and feel free to follow along with this tutorial. We're going to go ahead and select these 2 PDF files and upload them to the web app. Basically, we're starting from our last session where we defined the constraint expression a moment ago, x1 squared plus x2 divided by 2 squared. The only thing we have to do now is impose a side constraint for x1 and x2. So this would be -1.5, and I believe the value was 5. Here, let me look back at my PowerPoint. Here, side constraints. So, it's +1.5 and 5. So +1.5 and 5, and then I believe this one was -5 and 5. Now let's go ahead and go back to the exporter and download 2 new PDF files. Let's go ahead and create a new directory, 2.optimization directory. Let's go ahead and move these files to the recycling bin. We don't need those files anymore. We just downloaded 2 new files. Let's move those to the optimization working directory and start Nastran. We'll go ahead and point that to the model PDF file and click run to perform the optimization. Now what we should expect is the same thing on the graph. This orange line was already extracted from a previous optimization with Nastran, and so we'll see that in a moment. So here, let's go ahead and see what the value is when it touches the side constraint. The value is 1.5 for x1 and 2 for x2. This is after the first design cycle, and the z value is 6.25. So let's go ahead and confirm these results. So to do this, let's open the F06 file and scroll to the very bottom and make sure that it says run terminated due to hard convergence. And that's the message we see here towards the bottom of the file. And now let's look at this. Again, this column is reporting values for the objective function. So at the very initial design, we had a value of 25. The very initial values were 3, 4 for x1 and x2. And then, of course, if we look back at the graph, this is 25 and 3, 4. So design cycle 1, if you recall, has a value of 1.5, 2 and a z value or f value of 6.25. If we look at the next design cycle 1, you see that the objective value is 6.25. And here, the new value for x1 and x2 is 1.5 and 2. And this matches the expected result that we saw here. So you see these points are the same points from the F06 file. Later on, your variables might represent thicknesses if you're dealing with panels. If you're dealing with composites, the design variables might represent thicknesses of the plies, orientation angles. Your objective function might not be an algebraic function as I showed here a moment ago, x1 squared plus x2 squared. Your function might be the weight of the structure as an example, and your goal is to minimize the weight as much as possible. Exercise the same concepts you've seen so far. Optimization is nothing more than finding a minimum or a maximum for a given function. So that's the end of this tutorial. In the next tutorial, I'm going to show you what happens when a solution cannot be found. Here I have two ellipsoids, green and red. When we are looking for a solution that is within both of the same ellipsoids, but here you can see no such solution exists. This happens in structural examples. When design that satisfies all of your stress constraints, as an example, will sometimes not exist. How do you catch this in the optimizer? How do you sort of learn when this happens? And then in the same tutorial, I'm going to walk you through the process of fixing it. How do you relax the constraints so a solution can actually be found and an optimized model can be found? So you can expect that in the next video. So I believe that's the next video coming up in this playlist.